Merhaba arkadaşlar, benim adım Muhammed Abdullah Muhammed. Bu videoda yapı fiziği hakkında bahsedeceğim. So, hello guys, how are you? I hope you're doing well. In this video, I will talk about engineering physics. So, what do you know about engineering physics, or what comes to your mind when you hear engineering physics? Engineering physics or engineering science refers to the study of the combined disciplines of physics, mathematics, chemistry, biology, and engineering, but particularly computer, nuclear, electrical, electronic, aerospace, materials, or mechanical engineering by focusing on the scientific method as a requires passes it seeks ways to apply, design, and develop new solutions in engineering. So we'll go to the next page and we'll have an overview about our topics. Our topics, unlike traditional engineering disciplines, engineering science is not necessarily confined to a particular branch of science. Engineering or physics, instead, engineering science is meant to provide a more thorough grounding in applied physics for a selected, especially such as optics, quantum physics, material science. So, in our topics, we have two definitions. The first definition of engineering physics is the most basic science that models and understands the real world. It's the root of why other science actually works. And we have the second one. Engineering physics is an approach to engineering that seeks to understand the common underlying rules of all engineering disciplines. And also, engineering physics, it's not engineering for physics, but engineering with a physics approach, study and understand the root of why all engineering fields work, so you can design anything. So, what is the difference between engineering physics and other majors in engineering? The fundamental difference between engineering physics and other engineering majors is that engineering physics students study the same advanced basics topics as physics majors. In particular, at least 2 quarters of quantum mechanics and at least 1 quarter of statistical mechanics. So our topics, it has so many branches. It has secondary branches and main branches. Now, the first one we will talk about the main branches, which is the first one is metallurgy. Metallurgy is a domain of material science and engineering that studies the physical and chemical behavior of metallic elements, their intermetallic compounds, and their mixtures, which are known as alloys. And the second one, we have acoustics. Acoustics is a branch of physics that deals with the study of mechanical waves in gases, liquids, and solids, including topics such as vibration, sound, ultrasound, and infrasound. And the third one, accelerator physics. Accelerator physics is a branch of applied physics concerned with designing, building, and operating particle accelerators. As such, it can be described as the study of motion, manipulation, and the observation of relativistic charged particle beams and their interaction with accelerator structures by electromagnetic fields. The fourth one, which is called astrodynamics. Astrodynamics, which has the second name orbital mechanics. Astrodynamics is the application of ballistics and celestial mechanics to the particle problems concerning the motion of rockets and other spacecraft. So the fifth one, ballistics. Ballistics is the field of mechanics concerned with the launching flight behavior and impact effects or of projectiles, especially ranged weapon munitions such as bullets, unguided bombs, rockets. And the final one of our main branches, which called photonics. Photonics is the physical science and application of light, which called photon generation, detection, and manipulation through emission, transmission, modulation, signal processing, switching, amplification, and sensing through, through covering all lights technical application over the whole spectrum. Most photonic applications are in the range of visible and near infrared light. So we have talked about the main branches. Now we will move to the secondary branches, and the first one is plasma physics. I will talk about them quickly. So plasma physics, plasma physics is one of the four fundamental states of matter. It consists of a gas of ions, atoms, or molecules, which have at least one orbital electron stripped and thus an electric charge. And the second one, which is called cryogenics. Cryogenics in physics, cryogenics is the production and behavior of materials at very low temperature. And the third one, social physics. Social physics is the field of science which uses mathematical tools inspired by physics to understand the behavior of human crowds. And the fourth one, the fourth one, optical fiber. Optical fiber is a flexible, transparent fiber made by drawing glasses, which called silica, or plastic to diameter slightly thicker than that of human hair. Optical fibers are used most often as a means to transmit light between the two ends of fiber and find wide usage in fiber optic. So we have the fifth one, laser science. Laser science or laser physics is a branch of optics that describes the theory and practice of lasers. And the last one, and it's the most famous engineering that we all know about it. It's mechanical engineering. Is an engi- Mechanical engineering is an engineering branch that combines engineering physics and mathematics principles with material science of design, analyze, manufacture, and maintain mechanical systems. So thank you guys for listening and see you in other topics. Have a nice day.